If you are listening to this, you should have already replied to the announcement for today saying that you are here so that, well, I know you're here. Today we're going to be talking about graphing circles given an equation like so. The homework is circles number 8, and we'll be doing only the evens due by the end of class. All right, so obviously, we've not talked about graphing circles via these equations, so let's kind of talk about what we're looking at here so we can figure out how to graph them. All right, let's start with the orange here. This is the standard equation of a circle. We have this x minus h here on the left. Oh no, I need that. Go back there. Okay. We have the x minus h squared, quantity squared, plus y minus k, quantity squared, equals r squared. The reason it looks like this is because it is derived from Pythagorean theorem. That's why I put Pythagorean theorem up here. Okay, that's why we have, oh my gosh, how did I do that? Undo it. Okay, so that's why we have quantities squared here, and the radius, that r squared, is, well, also squared. It's based off of Pythagorean theorem. We're not going to get into all the particulars, but that is just why the equation is the way it is. So let's talk about what some of these letters mean. H and K is probably new to us, not as difficult as one might first think. The H value, okay, and the K value are both going to be values for the center of our circle. That dot that's in the center is going to be H and K. When we refer to the center of circles, we call the points H and K, and H is the X value of the center, and K is the Y value. Since we're using the coordinate plane here, right, if I have a center, if I have an H of 3 and a K of 2, that means the center of the circle is when X is 3 and Y is 2. So right there would be that center dot of the circle, and we draw the circle around it. Okay, don't draw that though. That's not the answer for that one at all. That was just an example. Okay, let's go back here. All right, so the center is values H and K. Now these negatives, these minuses here, are gonna mess with us just a little bit, and I'll show you how they affect how we plot the circle in the graph when I get to the examples. Last, since it's based off Pythagorean theorem, whatever's on the end here is the radius squared, okay? And just as a reference, like right here is the radius squared. That's not the radius. 16 is the radius squared. So we'll show you again how to figure out the radius, because in this problem, the radius is not 16. The radius squared is 16. I want to know what the radius is. Okay, so we'll get to that in a second here. All right. So a second is now. Let's do this. Let's graph this first problem, okay? So we know that our H and our K, okay, come after the X and the Y. The X and the Y represent any point that's on the circumference of a circle. So if I had like a circle here, any point on this circle could be represented by this X and this Y. But for our case, the X and the Y will just be variables in the equation. We do not do anything with this X and Y for now. So they're just always going to be there. What's important are these twos, okay? Now, if you guys remember, the equation is X minus H and Y minus K. And I said that's going to mess with us a little bit. So if you think that H is 2 and K is 2, you would actually be wrong. For the center, okay, if you thought that H was 2 and K is 2, you would have been incorrect. This would have been wrong. Okay, it is not 2 and 2. Because there's supposed to be a minus here, really, it's like I'm taking the opposite of what is shown in the equation, the opposite of. So if I have X plus 2 here, I'm just going to focus on the first one. If I have X plus 2, that's a positive 2. But remember, I want the opposite. The equation originally states it goes X minus H. Well, that's a plus, okay? So I have to take the opposite, okay? And that's based off the original equation. So h is not 2. H is actually, oops, I guess pink's fine. H is actually -2. And the same with K. K is also -2. So the center, let me move that to the other side. I don't like it on this side. It's too crammed. It's too crowded. Move over here. Okay. So the center is -2, -2. To make it easy on us, when we're looking at these equations, whatever number is written here, right? If it's +2, it's going to be the opposite, -2, right? If it's +2, it's -2. And we look to this next, that's +4, so the center is going to be -4. This is -2, it's going to be +2. Okay, so we'll come back to that one. All right, so the center is -2, -2. We can plot that point right now if we want. Center is, so I start at the origin. X is -2, Y is -2. So there's my dot. Don't put those lines there. Just right there. X first, X -2, Y is, that's going to be the center of my circle. Okay. Next part is finding the radius. And the radius is here. But again, back to the original equation, that 16 is actually the radius squared. Okay, so the radius squared equals 16. The radius is not 16. The radius squared is 16. So what is the radius? What does the radius equal? What number squared gives me 16? I'm sure if you had a second, you could figure it out. The answer is 4. 4 squared is 16. So my radius of my circle is actually 4 and not 16. So when you have these numbers on the end, like 16, or for the next example, 4, that's not the actual radius. That's the radius squared. So if the radius squared is 4, for number 2, I think we can figure out that the actual radius is 2, because 2 squared is 4. Another way you can think about it is that when you're looking at this number at the end here, just think, what is the square root of this number, right? What's the square root of 4? It's 2, and look, that's my radius. All right, so we have our radius here. Radius is 4, and we have our center already plotted. So I'm now going to go ahead and plot the radius, and here's how we do that, nice and easy. Start at the center, right? I'm at the center, and just count. My radius is 4, right? Count 4 spaces up, down, left, and right. 1, 2, 3, 4, and put a big old dot there. That's up. Let's go down. 1, 2, 3, 4. Put a big old dot there. Go back to the center, to the left. 1, 2, 3, 4. That's a little oblong. Okay, and then to the right. 1, 2, 3, 4. Now, if we were in school, we would be doing this all freehand, but hopefully we'll have notability, so our circles can be nice and pretty. Watch this. Let's go ahead and just connect these dots. Not my best work, but I think when I connect it and hold it down, ta-da! It's a pretty little circle, and there you go. There's our circle. We graphed our first circle. Now these little dots are kind of throwing it off. I don't like those, but what I need to see is the center, and then those 4 points from the center, and then you just draw a circle all the way around, and there you go. Okay, so what I need to see, number 2, which I'm about to do, is going to be what I need to see for every even moving forward. Okay, so let's look at number 2. I already found the radius because I moved ahead a little bit. The radius is 2. Now what's the center, right? What's the center? So I'm going to do my little... We'll go all magenta for this one. Okay, so here's my x value, right? Remember, it's the opposite. So if it's x plus 4, I need the opposite of that. That's -4. And if my y is -2, I need the opposite of that. It is +2. So there's my center, and there's my radius. Boom, boom. You're ready to graph. Go to the graph, do the center first. The x is -4. You always start at the origin and count. So x is -4. 1, 2, 3, -4. Okay. And then y is 2. That's up 2. 1, 2. Boom. There's the center, oh no, of my circle. Center of my circle. Now, I know the radius is 2. So I'm going to go in, and I'm going to go up 2, 1, 2. Come on, man. Up 2, to the right 2, to the left 2, down 2. There you go. I have 4 points that are going to be on the circle, and now I just connect them. Ooh, hopefully this ugliness will be fixed by Notability. Yeah. Look at that. Boom. Circle. Graphed. Done. Let's jump to 4. Okay. Center first. Look at the numbers. We have a 3 and we have a 2. Remember, take the opposite. The center is -3, -2. The radius, 2. You have to square root this number. Remember, this number here is radius squared. I want to know what the radius is. The radius is 2. So the center is -3, -2. There's my center. And the radius again is 2. So up 2, down 2, right 2, left 2, and connect them. If you don't have Notability, your circles don't have to be the prettiest, but I need to see that you're drawing circles as best you can. Okay, and you just carry on that way as you go on. Now there's another thing that we'll see. If you look at number 6, you'll notice that it's just x squared. It's not in the parentheses. This is quite easy. That means that for my center, the x value of the center is 0. Okay, if you want, you can imagine it as, okay, it's x minus 0 squared, but you would never write this. Why would I subtract 0 from something? What's 10 minus 0? You'd never write that because it's just 10. So whenever there's just a plain variable, whether it's x or y, right, it's not in parentheses and there's no number accompanied by it, that just means its value is 0. So the h value is 0. And then the k, it's a -1 there, so that means the other one is +1. And my radius is 6. I know that because I just square rooted this last number. All right. So the center is x is 0 and y is 1. And my radius is 6. 1, 2, 3, 4, 5, 6. All right, 6. 6. 6. And there you go. Connect away. Let's see how nice I can make this one. What the heck is that? What did I just make? All right, let's try that again. Maybe we gotta zoom out a little bit. Let's make it a little smoother. Come on, circle. No. Oh, man. All right. All right, I'm going to sit up for this one. Here we go. Nice circle. Boom, boom. Oh, gosh. Oh, gosh. All right, well, you get the idea. Boom, boom, boom. Circle. All right. And there's another one just like it, so you get a little more practice. Evens, evens, evens. I don't see anything here that should be particularly challenging. Okay. Nice, nice, nice. Oh, maybe this one. All right, the last thing, right? Yeah, okay. If you have, so for example, this very last one, if you look at the radius, now the center is the same. This is my h and k, that's the same. But look at the radius. The radius squared is 21, and if I asked you what the square root of 21 is, I hope anyone wouldn't have an answer because it's not a perfect square. With a calculator, just go ahead and put the square root of 21 in your calculator. Okay, it'll be 4 point something. All right, so do like a 4 point. You could round it to the tenths. That's fine. Okay, and then just when you count off your radius, your center is -1, -1. So if it's like 4 and change, I'd go 1, 2, 3, 4, a little bit over. Right, that's fine. Right. 1, 2, 3, 4, and just a little bit over the mark. That's fine. You can kind of approximate there. All right. Last part. Let's talk about, it's going to be write the equation now given the center and the radius. So if I give you the radius and the center, you should be able to write the standard equation. This is my h. This is my k. All right. So it's going to be x minus. It's always x minus, right? X minus. Well, not always x minus, I guess. We're going to have some x pluses in here, but so maybe let's get rid of that. Okay, x, now if my h is 7, remember I want the opposite, so it's negative 7 squared. Everyone forgets to put the squares. Remember, it's based on Pythagorean theorem. We're squaring everything here, all right? The k is going to be y, and then the opposite of 6 is negative 6 equals, all right, so even if the radius is something like this, like, oh my gosh, what do I do with that? Well, whatever it is, remember, we had to square root to get the radius. So what's the opposite of square root? We're going to square to go the other direction. So if I give you the radius and I want to put it here, on its way to going here, I have to square it. Square. So what is root 11? Oops. Root 11 squared. Root 11 squared, well, convenient enough, square cancels out square root. So the square of root 11 is just 11. Boom, done. Problem solved. There's my equation for 22. How about 24? All right. X. Now look here. It's a negative 2. I do the opposite. Plus, well, if it's 0, remember what I told you? I kind of started the parentheses already. Get rid of that. If it's 0, just write it like that. Y squared. You don't have to write y minus 0 squared, just y squared, kind of like the example that I did earlier. Equals, and now I'm not going to put a 10 here, okay, since I'm writing the equation. Now remember, what has to go here is the radius squared. Go back to the beginning of the video. The equation of a circle has the radius squared. So that's my radius square this number. That number squared is 100. Boom. Got it. Last one. Here we go. X, the opposite squared. I forgot my squared over here. I knew it. Go back. There it is. Plus y, the opposite squared equals, what is root 7 squared? It's just a regular 7. Nice. Okay. Last one. Oh, we gotta do these, right? All right. 2 to the 5th squared. If you have your calculator, go ahead and just put this in parentheses. Okay, put that in parentheses and square it. You should get the answer. But if you don't have a calculator, as I've asked you to get all year, you're trying to use your phone calculator. Okay, you're gonna have to do 2 root 5. Oops. 2 root 5 squared. 2 root 5 squared. Okay, and I'm actually, when you square 2 root 5, you have to square this and square that. So that's going to be 2 squared, right? 2 squared is 4. Okay, and I put a little dot there because we're multiplying these. 2 root 5 is 2 times root 5. So I put a little dot here. 2 squared is 4. And what is root 5 squared? Well, it's just 5. And what's 5 times 4? So there's my radius, 20. It's a whole lot of work, but that's my radius. My radius is 20. So when I write the equation, x, x opposite plus y opposite squared equals, and then I just said my radius is 20, right? There you go. All right, good luck. Finish by the end of class and turn it in. Uh-oh. Oop, finish by the end of class, turn it in. Sorry, I messed up.